Hi everybody, this is Mr. Longo here, and we are going to cover functions in this video. So a function is going to be a specific kind of relation. So let's talk about our vocabulary first. A relation is just a mapping of inputs and outputs. So it can be data collection, it could be just any old relationship whatsoever. We have inputs and outputs. Now most of the time in algebra, our inputs are going to be denoted with an x value. Our outputs are usually a y, but note that those variables can be changed to any letter we need to work with, okay? Our input value is our domain of a function, and it's the independent variable. Now, what comes out of that function is known as an output, or the range of a function. And that is denoted as the dependent variable because your output depends on what you put in it. So that's how input is independent and output is dependent. A function is a very specific kind of relation that maps an input to exactly one output. Okay, so think of it this way. Think of a pop machine. You push the orange crush button or whatever and you get an orange crush out of it. And then if you were to put some more money in there and you would push orange, you expect an orange to come out of it. That is a function. Every time you push orange, you should get an orange pop. Now, if you went up to a pop machine and pressed the button and one time you get orange and then you push the button again and you get a Dr. Pepper and then you push the same button a third time and this time you get a Sprite. If you get a different drink each time you push the button, then that's not a function. For a function to work properly, every time you substitute something into that function, you should get the exact same result every time. Okay, so that's a function. Now, function notation is just this. It's a letter that represents a function, and the little thing inside, the little variable inside the parentheses, that's the variable that we're going to be working with. So we can do all sorts of different things. We can do h of a or y of b. There's a whole bunch of different names. It's just that's what it looks like, okay? So let's go talk about whether or not things are a function. So this next section right here, we're just going to be saying yes or no. Is it a function? Yes or no. So the key is to remember the definition of a function. It's a relation that maps an input to exactly one output. So these two are very similar. They have the same inputs. We input a 1, we get a 2. We input a 3, we get a 4. We input a 5, we get a 6. So when we go back and input a 3 again, we should get a 4, and we do. So this is a function. Now, exact same set of inputs, but this time I just switched it up a little bit and went 1 to 2, 3 to 4, 5 to 6. So then I went back to 3. But this time the output is an 8. That is not a function. It's like pressing the orange button and we get an orange pop, and then 2 seconds later we press the orange button again, but now we get a Pepsi. Not a function. So since 3 gave us 4 and then a little later 3 gave us 8, that is not a function. It is not allowed. Okay? So that's in like your little 2-column, also known as little t-tables. This next format is just listing coordinates. So if you were to just look at these, think about the coordinates, they're x comma y. Is h of x a function? Is j of x a function? Think about that and let's see if you can think about it correctly. Which one is a function? I'll tell you one of them is, one of them is not. If you said that j of x is the function, you are correct. J of x is a function because 2 gives you 3, 3 gives you 3, 4 gives you 3. But notice, we didn't repeat any inputs. If I would have said that 2 gives you 3 again, we're good to go. The issue is here's our input, x, 1 gives us 1. But then in the next coordinate, we start with 1 again, but this time we get 2 out of it. And then we plug in a 1 and now we get 3 out of it. That's not a function because it is giving you a different thing each time you plug in 1. So that means it is not a function. And the last thing we can do is we can look at it graphically. So let's just look graphically. This is like, negative 10, negative, whatever. We're just going to think about this in terms of x and y values. So look at how many different x values you have. We are starting in negative infinity and going to infinity because of the arrows. But notice every time we only have one output. And how do I know that? Well, here's a little shortcut for you. It's called the vertical line test. If you draw vertical lines from left to right, if it touches the graph only one time per vertical line, it's a function, okay? It's called the vertical line test. And it tells you if that graph is a function. So if your vertical lines were to touch the graph more than once, it can't be a function. I'll show you in just a second. But these, every time you draw a vertical line, it only touches the graph once. So yes, it is a function. So let's slide over here and let's draw vertical lines again. And as you can see, it doesn't take long to see that every time you draw a vertical line in this situation, we have two different outputs. That's not good. That means this is not a function, but let's think of it a little bit deeper here. Give you an example. We're just going to pretend that this line I graphed over here has a value of 1. We'll just call that x equals 1. And this looks like we're down about a negative 1, but over here this looks like we're up at 3. So this coordinate is like 1, negative 1, and this is 1, 3. Well, that goes back over here to show you that we're getting different values each time we substitute in a 1. And the same thing at 0, same thing at negative 1. So if you draw vertical lines through a graph, and if that vertical line hits the graph more than once, it is not a function, okay? Another thing we're going to do with functions is evaluate them. So there's a whole bunch of different types of ways to evaluate functions. I'm going to do one example, and then you're going to try a couple examples as well, and then we're going to just take turns, okay? So when I tell you to pause the video, just pause the video, answer the question or questions I ask you to, and then as soon as you're ready, click play. So this, we're evaluating using a table. So this basically is telling us that function f is equal to 2x minus 1. And when we evaluate a function, we're just substituting this x value of negative 1 into the function and see what we get. Now you can show your work if it's helpful to you. So if I were to say find negative 1, or what does f of x equal when x is negative 1, we would just say 2 times a negative 1 minus 1. 2 times a negative 1 is obviously a negative 2, minus 1 is going to give us a value of a negative 3. So that's how you substitute. I'll show you once more. Now x is 0, so 2 times 0 minus 1. So 2 times 0 is obviously 0, minus 1 is a negative 1. That's how you evaluate in this format. So what I would like you to do is pause the video and find what x or f of x equals when x is 1 and 2. As soon as you're ready, click play and we'll see if you got them correct. So for this, we should have 2 times 1 is 2, and then of course minus 1 is going to give us 1. And then for the next one, if you did 2 times 2 minus 1 and you got 4 minus 1 is 3, you are correct. That is how you evaluate a function, by substituting it in a table. Now there are some other ways to evaluate as well, and that's by when you're given the function and you're just asked to say find g of 5. Well, what that means is find the value of g of x when x is 5. See, notice that we have inside the parentheses is x. So that's telling you that x is equal to 5. So that would just be saying negative, and I always substitute in my values in parentheses. Always, always, always. It'll be a lot more helpful to you. And then of course plus 3. So we have a negative 5 plus 3. That's going to give us a negative 2. So g of 5 is equal to a negative 2. Simple substitution. So again, pause the video and try finding g of negative 2 and g of 0. And as soon as you're ready to see the answers, click play, and I'll see or I'll show you if you got yours right or wrong. So g of -2, that one might have tricked you because remember I told you when you substitute you should use parentheses. So the negative is already here, but then our x value is a -2. And then we have plus 3. So a -2 is actually a +2 plus 3. You should have 5 for that one. Now if you have a 1 this time, you just forgot that a negative is going to turn into a positive. Finally, g of 0, that would be a -0, which of course we know doesn't exist, so 0 plus 3 is equal to 3. So when you are substituting, like I said, it's sometimes helpful to make sure that you are using parentheses. Last example, we are going to evaluate using a graph. So remember when we are working with a graph that our horizontal axis is our x-axis and our vertical is our y-axis. And when we're evaluating here, this is saying find h of -2. Well, that's basically saying what is the value of the graph when x is -2. So to do that, there's multiple ways. You can just look at it and kind of already understand, or if it's helpful to you, you can just kind of go look where x is -2 and just draw a vertical line because that represents x is -2 until you get to the part of the graph. So that coordinate right there, we can look, is -2, -2. So if x is -2 on this graph, our y value is a -2. Okay? So I'll show you one more time and then I'll let you evaluate one. So this says find h of 0. So where is x 0? So you go to where x is 0, and I'm going to draw a vertical line again because remember, this is x is 0 every time. This is 0, -1, 0, 0, 0, 1, 0, 2, and in this case, 0, 3. So this red graph at 0 has a y value of 3. Okay? So I want you to pause the video and tell me what h of 2 equals. Click play when you're ready. So for h of 2, we would actually just go over to where x is equal to 2, and you should see that we're already here. We are on the x-axis, so that coordinate would be 2, 0. So if x is 2, our y value is 0 for this graph. Okay? So if you got that, great job. So I'm going to show you a different type of evaluating. We're going to go backwards this time. So this one is saying that h of x is equal to a -4. So our y value is a -4. So what x values give you that? So to do that, you're going to go to where y is equal to -4 and draw a horizontal line. Remember, horizontal lines represent y values. So this would be like 0, -4, 1, -4, 2, -4, until we get all the way over to here, which would be 4, -4. So the x value that gives us a -4 is 4. So this last example is yours, and then we'll be done with the video. I will tell you this is a little bit of a trick question, though, because it has more than one answer. Now, this is still a function, as you can see. That's because I'm giving you the output. You have to give me the input. So this says h of x is equal to 0. Which values will give you 0? Hint is there's more than one. Pause the video, think about it, and see if you get it right. So here we go. If we draw a horizontal line at y equals 0, we hit 1, 2, 3 different points. So if you listed x was equal to a -3, a -1, and a +2, you are correct. So that completes this video. And again, this just covers some basics of functions and how we evaluate them. And we can also determine whether or not a function or a relationship is a function in different ways based on the types of outputs or using the vertical line test if this is a graph. Okay, so anyway, that is it for this video. This is Longo and I'm out. See you, bye.